Good morning, good afternoon, good evening. Hope you're all well. So today we are going to discuss the third problem in the Codeforces Round 975. The problem name is Cards Partition. So let's get started. Let's start by reading the problem statement first. You have some cards. An integer between 1 and n is written on each card. Specifically for each I from 1 to n, you have a of I cards which have a number I written on them. There is also a shop that contains unlimited cards of each type. You have k coins, so you can buy at most k new cards in total. The cards you can buy contain any integer between 1 to n inclusive. After buying the new cards, you must partition all your cards into decks according to the following rules. All decks must have the same size and no two pairs of cards with the same value in the same deck. Find the maximum possible size of the deck after buying the cards and partitioning them optimally. We'll be given an n and a k, and we'll have n integers, the number of cards for each number, and we need to output the maximum possible deck size if we separate them optimally. So let's take the second test case to understand the problem. We will have 5 cards. So the cards with 1 written of them would be 2, with 2 written on them would be 6, with 3 written them would be 1, with 4 would be 2, and with 5 would be 4 cards. So we'll have 2 cards with 1 written on them, 6 cards with 2 written on them, 1 card with 3 on it, 2 cards with 4 written on them, and 4 cards with 5 written on them. So we need to divide them into decks such that all the decks are of the same size and no pair of cards with the same value in the same deck. Like in one deck, all the numbers are unique. So what is the maximum deck size we can have here? Like we can put all the numbers in this array, right? So 1, 2, 3, 4, 5. So the maximum deck size can be n and the minimum deck size would be 1. Like 1 is always possible. I will just have a card, right? So our answer lies between 1 to n, right? So another thing we can note from here is whatever is this maximum number, our number of decks would always be greater than that. Let's suppose I have 3 decks. If I make 3 decks of any size, let's suppose I'm fixing the number of decks right now as 3. Now if I try to divide these 2s into these decks, so it will be 2, 2, 2, 2, 2, 2. So this combination is not possible. Like it is not allowed. Right? So the number of decks would be always greater than or equal to the maximum amount of cards. Right? Let me make 6 decks now. And 6. So if I have 6 decks, so I can have 2, 2, 2, 2, 2, 2 and 2. Right? So it won't repeat here. Like if I had 7 2s, then only it would repeat. In this case, it would not come here. Now, even if we had 7 decks, let's suppose we had 7 decks. So one deck would not have a 2. So that doesn't matter. We don't need all the decks to have the same numbers. Right? So I can put anything in this. So this statement is always valid now. Like the number of decks is always greater than or equal to the maximum amount of cards of number. Like we had the maximum number of 6, so the number of decks would be greater than or equal to 6. Now another thing that we can see here, like we have a total number of cards. We are given the sum of cards. Like we will find the sum of cards. For this, the sum was 2 plus 6 is 8, plus 1 9, 9 plus 2 is 11, and plus 4 is 15. And what is the maximum number of cards that we can have? So this is sum plus k. Like we can buy at most k cards more. Let's suppose the k here was, like what is the k given? So we are given 4 here. So we can have 15 plus 4, that is 19 cards at most. Now we can just iterate over. This is the maximum number of cards and this is the number of decks. So let's suppose we have a deck size of x. So what is the number of decks? That would be the maximum cards, this divided by x, and the number of used cards would be x into max cards divided by x. This is the lower bound since this is an integer. So this number, like this number should be greater than the number of cards we initially have. Like we can increase the number, but we cannot decrease the number. Let's suppose this number was 15, but initially we had 16 cards. So then it would not be possible. So we need to keep this condition in mind and this condition, that the number of decks should be greater than the maximum number of cards for a given number. Right, so let's write the conditions. So the conditions are: the number of decks should be greater than or equal to the maximum amount of card of any card. This is the first condition. The second condition is total used cards should be greater than or equal to the number of cards we have. Right? If these both conditions are satisfied, then we can have our answer as that deck size. Whichever deck size satisfies these both conditions, we'll have the answer as that deck card. Right? So let's write a little bit of code for this. We'll have an input. So the inputs are n and a k, and we will input the vector as well. These are the number of cards. While taking the inputs, we will calculate the sum of cards. Like what is the total number of cards? Like this is the total number of cards and the maximum amount of any card. So we would find these both while taking the input itself, and then we will have the maximum cards possible. That would be sum plus k, right? And we will have an answer variable that is initially 1. Then let's suppose we iterate from 1 to n. Now we will have the number of decks as the maximum cards divided by the deck size. So this is the deck size, and the used cards would be deck size into decks, number of decks. Now if the conditions satisfy, conditions are true, like these both conditions are true, then we would have our answer as the I, whatever this number is, and we can break. Like since we are iterating in the reverse order, then we can simply break, and in the end we will just print our answer. So this is the code. I hope you understood the approach. Do dry run this for once, like how we are getting this, like how did I think this one. Do think upon this once more and you will understand it better. Let's move on to code the same. So I have my boilerplate code here. We'll be given an n and a k. We will take them as inputs. Okay, we'll have a vector of ll size n. We will take the array also as input. Now we will define the number of cards is initially 0 and the max amount of cards. We will add the number of cards into our total sum. The sum is number of cards, and for the maximum amount we will update it with the maximum of the current and the ARR of I. So whatever is the maximum count of one particular kind of card we can have, then we will have an answer as 1, and the maximum cards possible is the number of cards plus k. This is the maximum number of cards possible. Now we will iterate. The deck size is n. We will have deck size is greater than 1, and we will decrement the deck size for each iteration. So we will have number of decks that is equal to the maximum amount divided by the deck size, and we will have used cards equals to number of decks into deck size. Right, now the two conditions, like used cards is greater than or equal to the number of cards that we have initially, and the number of decks need to be greater than or equal to the maximum amount of one card. Like the maximum amount of cards, like one card. This needs to be a single s. So maximum amount of a card. How many times this a single card occurs, and this is maximum cards possible. So if both the conditions satisfy, then our answer is that particular index, and we would break, and in the end we would just print the answer. This is our code. Now let's try for the sample test cases once. and it passed all the given sample test cases. Now let's try to submit it. Submit, problem is C, paste and submit. It is running on test case 4 and it got accepted. That means our solution and our approach is correct. I hope you understood the problem. Comment down what was your approach for solving the same problem. The solution link would be in the description section. Do check it out. Like the video, subscribe to the channel and share it with your friends. Thank you.